Hello students, welcome to section 15. In this section we will be doing an extra question outside of the textbook, and we'll do a question from our problem set 1.4, or rather practice set 1.4, and we'll be completing 1.4 in our next section. Now this section will also include some extra problems so that you practice these kind of problems in order to perfect them. So now here I have a question that has 1 upon x minus 2y plus 1 upon 2x plus y is equals to 1 divided by 6, and I have 5 divided by x minus 2y plus 15 divided by 2x plus y, which is equals to 3 divided by 2. Now I have my both equations. The first step, as usual, is to replace the equations by some unknown variable outside of x and y in order to get a linear equation. So I'll be replacing 1 upon x minus 2y as m and 1 upon 2x plus y as n. So this implies I have m plus n is equals to 1 by 6 in the first equation, which when I solve further gives me 6m plus 6n is equals to 1. This is my equation number 1. Now for equation number 2, I have 5 into 1 upon x minus 2y plus 15 into 1 upon 2x plus y is equals to 3 by 2. Replacing 1 upon x minus 2y by m, I'll have 5m plus, replacing 1 upon 2x plus y by n, I have 15n is equals to 3 by 2. Once I solve this equation further, I'll get 10m plus 30n is equals to 3. This is my equation number 2. Now I'll be solving this equation, the pair of equations by elimination method. So first I need to multiply equation 1 by 5. That will give me 30n, and therefore I'll be able to eliminate n. I have 6m into 5 is 30m plus 6n into 5 is 30n is equals to 5. This is my equation number 3. Now I'll be subtracting 3 from 2. So I'm going to subtract equation 3 from 2. So my second equation was 5m. My second equation was 10m plus 30n. 10m plus 30n is equals to 3, minus my third equation is 30m plus 30n. 30m plus 30n is equals to 5. Now we have a minus sign, therefore I need to make sure all the sign inside the bracket changes. This is minus, this is minus, this is minus. So I get minus 20m is equals to minus 2, which implies m is equals to 1 upon 10. Minus minus cancels, and 2 tens are 20, therefore I am left with m is equals to 1 by 10. Once I get m is equals to 1 by 10, I'm going to substitute this value. In equation 1, my equation 1 is 6m plus 6n, so therefore I have 6 into 1 by 10 plus 6n is equals to 1, which implies 6 by 10 minus 1 is equals to minus 6n. I have taken the 6n to the right hand side and brought the 1 to the left hand side. Solving 6 upon 10 minus 1 gives me minus 4 divided by 10 is equals to minus 6n. Minus minus cancels out, and eventually I get n is equals to 2 divided by, this is 2, this is 3, 30, which is equals to 1 by 15. So I have n is equals to 1 upon 15. Make sure you highlight your answers so that you don't face any problems while picking them back up. Now, my m was equals to 1 upon x minus 2y, and n was equals to 1 upon 2x plus y. But my m value is 1 by 10. So 1 by 10 is equals to 1 upon x minus 2y, and my n value is 1 by 15. So 1 by 15 is equals to 1 upon 2x plus y. Taking the values to the opposite side by cross multiplication on equal to sign, I'll get x minus 2y is equals to 10, and I get 2x plus y is equals to 15. This is my equation number 4. This is my equation number 5. From 4 rather, I get x is equals to 10 plus 2y. So I'll be substituting this x value in equation number 5. That gives me 2 times 10 plus 2y plus y is equals to 15, which implies 20 plus 4y plus y is equals to 15, which implies 20 plus 5y is equals to 15, and 5y is equals to 15 minus 20, which implies 5y is equals to minus 5, and therefore I have y is equals to minus 1. Now once I get y is equals to minus 1, all I have to do is substitute it in either equation 4 or 5. So substituting y is equals to minus 1 in equation 4, I have x minus 2 into minus 1 is equals to 10. This implies x plus 2 is equals to 10, which implies x is equals to 10 minus 2, which implies x is equals to 8. So therefore I have a solution x comma y is equals to 8 comma minus 1. Make sure in order to understand this particular problem, you go slow. This was a quite lengthy problem, so there's no need to panic even if you don't get it the first time. Just rewind the video and try it out again. You will be able to do it. Now moving on to our practice set. So this is practice set 1.4. I'm going to attempt question number 2 from sub-question 2 from question number 1. So my question number 2 is 10 divided by x plus y plus 2 divided by x minus y is equals to 4, and 15 divided by x plus y minus 5 divided by x minus y is equals to minus 2. So again I start by replacing 1 by x plus y by m. and 1 by x minus y by n. Make sure you write replacing here, otherwise the person who checks your solution will not understand what you're trying to do. So once we replace, I have 10m plus 2n is equals to 4, and I have 15m minus 5n is equals to minus 2. This is my equation number 1. This is my equation number 2. Now I'm going to use Kramer's rule over here. So this is in the form a1m plus b1n is equals to c1. This is a2n minus b2 plus b2n is equals to c2. So I have a1 is equals to a1 is equals to 10, a2 is equals to 15, I have b1 b2 as plus 2 and minus 5. I have c1 and c2 as plus 4 and minus 2. All I'm doing is comparing the coefficients. I know that the way I have compared the equations in this particular problem is different from what we have been doing in the past Kramer rule questions, but make sure every time you check the coefficients, all you have to do is check the same coefficients. These two are same, these two, this is the value of this, this is the value of this, this is the value of this. All of this is interrelated. So make sure you do not make any mistakes while getting the coefficients. Now back to our solution. So my D value is A1, A2, B1, B2, which is equals to 10, 15 plus 2 minus 5. On solving this, I'll get 10 into minus 5 minus 2 into 15, which is equals to minus 50 minus 30, which is equals to minus 80. So my D value here is minus 80. Now remember, we are trying to find the value of m. So I have dm is equals to c1, c2, b1, b2, which is equals to 4 minus 2 plus 2 minus 5, which is equals to 4 into minus 5 minus minus 2 into 2, which is equals to minus 20 plus 4, which is equals to minus 16. So my dm value is minus 16. Now moving on to my dn value. So I have dn is equals to a1, a2, c1, c2, which is equals to 10, 15. C1 value is plus 2 and C2 value is minus 5. So when we solve this, I have 10 into minus 5 minus 15 into 2. Once again, this is my B1, B2 values. My mistake, I took B1, B2 values as C1, C2 values, but my C1, C2 values are 4 and minus 2. So this is 4, this is minus 2. So here I have 10 into minus 2 and minus 15 into 4. So this is equals to minus 20 minus 60, which is equals to minus 80. So dn value is equals to minus 80. Even though if I proceeded with the previous mistake I made, I would have received dn is equals to minus 80, but my procedure would have been wrong. It is very important that your procedure is right at all times whenever you're solving any kind of questions. So now m is equals to dm divided by d, and n is equals to dn divided by d. Now dn value is minus 80, my d value is minus 80. So this is minus 80 by minus 80, which is equals to 1. My dm value is minus 16. So here I have minus 16 and d value is minus 80. So m is equals to, this is 1 za, this is 5 za, m is equals to 1 by 5 and n is equals to 1. Now m is equals to 1 by 5, but m was also equal to, from our question, m was equals to 1 upon x plus y, and n was equals to 1 upon x minus y. So this implies 1 upon x plus y is equals to 1 by 5, and 1 upon x minus y is equals to 1. When we solve this, I get x plus y is equals to 5. This is my equation number 4, and x minus y is equals to 1. This is my equation number 5. All we have to do is add 4 and 5. That will give me x plus y is equals to 5 plus x minus y is equals to 1. So this becomes 2x is equals to 6, which implies x is equals to 3. So once I put x equals to 3 in equation number 5, that gives me 3 minus y is equals to 1, which implies 3 minus 1 is equals to y, and therefore I have y is equals to 2. So my solution for this question is x comma y is equals to 3 comma 2. I hope this section was helpful for you. If you still face any problems in these type of questions, we're going to revise this once again. For now, I have this homework page for you. Make sure you try these problems before you move on to practice set, or before you move on to trying any new problems. Now the question number 2 here is written in blue. That is because this question is very good to see how well have you understood the concepts of linear equations in two variables. Make sure you share your problem solutions with me regarding question number 2, and you have to do this as extra work and submit later when the school reopens. Thank you. This section will end now.